My name is Andrew Williams, and it's a great pleasure today to be speaking at Go West. My background is in software engineering, where I've been working for around 18 years across a variety of mobile, desktop, and server-side applications. Today, I would like to talk to you about how some of these learnings have helped me to see that Go is a really great language for building graphical user interfaces. And we're going to explore how Fyne makes this even easier. But first, a little background. There are so many challenges behind building graphical applications, and most of these, I feel, are because of the legacy that it brings with it. Things may have moved on a lot since the Xerox star that you see pictured there, but the software itself hasn't necessarily come quite so far, and the toolkits that we use now have about a 25-year legacy. They're mostly based on the C programming language, and you can kind of see how that's carrying through even into the modern updates like C# or Objective-C as well. Every day when working with these systems, you need to think about memory management, when do objects get created and how do they hang around. Thread handling is another challenge because traditionally a graphical system will require that all updates are messaged on the main thread or the thread where it was started. And that seems like something that we could have probably solved earlier. And many of them, because the languages are designed some time ago, happened before web services were really thought about, and so their support can be lacking. And some don't even have good string handling or the ability to manage templates. So why are we still using languages like that? Well, of course we don't have to. There are many modern languages that could be providing a lot of functionality and solving some of these challenges, but they haven't all found their own way to present graphical user interfaces. In fact, they are often just using bindings to old platforms, so you can use your language of choice, but still have to think about the challenges that underpin it. This, as well as the legacy, makes it quite complex to learn. A lot of people think that building a graphical app is a daunting effort and read a lot before they can really get started, but that should be something that could be fixed as well. And for something that's grown over such a long period of time, you might expect it's quite massive. There's a lot of options, there's a lot of functionality, but with that comes large weight, lots of documentation to perhaps try and parse through. And even getting started on some of these platforms can require a 40 gigabyte download that needs to be installed before you can even get up and running with a Hello World. Now this, I think, along with the other items above, is something that the Go language has really helped us to beat through its approach to being light, easy to understand, and quick to get started with. So that's why it might be able to help us with these legacy challenges. But its language design itself actually helps very much in these types of usages. Object composition is something that is really powerful when designing a widget system for a graphical toolkit. We can start with a very basic interface definition of what a widget is, so that most widgets can be implemented quite easily. And then we can provide a library that implements this interface for various standard types of widgets. As we see in the diagram, a widget could then be extended. By using composition, you can embed the functionality of the parent widget and add to it as a child. In fact, a new widget could compose many different existing widgets to create the desired effect by combining them. Multiple inheritance, I suppose that is a little bit like, although strictly speaking not the same, but the Go language and its flexibilities allow this. And with this design, developers can create their own widgets, they could extend existing ones, and also due to the nature of the packaging and importing of shared libraries, we can import widgets that exist from other code bases. These are really powerful aspects that have helped Go to position itself in a place where graphical user interfaces are easier to build. And of course, the main benefit here is that we've got the ability to build native apps on any platform. As with a standard Go executable, we're using one set of code to build on all the different platforms that we support. And of course, a graphical app could do exactly the same. It should be possible to build your app and have it then copied and deployed onto any system, assuming it matches the build parameters. But however that may be installed, you know that the same source code has been used to build all of them. And just like a native binary from Go standard command line, these are just going to work. They don't require libraries to be installed or additional setup to be run, which actually is quite common with the existing toolkit libraries on other languages. Much like the illustration on the previous slide, we can take advantage of modern techniques and language design. We've got testing built right in as well, which is quite unusual for graphical user interface toolkits. And quite importantly, we can lower the barrier of entry. We can make it very easy to get started, encourage learning and getting your first app out of the door in just a few lines of code and not many complications. An opportunity, of course, to shine here if we're building a new toolkit is to just have apps that look great as standard. We can design something that works well on all platforms instead of needing to use the same widgets as a system, and so the applications would then work and look differently across different platforms. And with all of the above, embracing Go's tools like doc and lint and so forth, we can promote good engineering principles as well. So there's the opportunity, and Fyne was designed to make most of all of these great things that come as part of the Go language. Let's have a look at building our first application. Well, there are a couple of prerequisites, so let's just quickly cover those. You'll need a working Go compiler, which hopefully everybody listening has already achieved. It needs to be at least version 1.14, but all of the newer versions will work as well. You need to have a C compiler that's installed and running. GCC and Clang both work. There are others available, although they may be less well tested, so I don't know how your luck will fare. Doing this may not be trivial on all systems, so here's a couple of hints about how you may find them. On BSD and Linux, you can just install the GCC package. That should be all you need. On macOS, Xcode is going to deliver all of the compiler implementation that you need, and it will also bring you the ability to install onto iOS devices. On Windows, I recommend using MSys2 and installing the Mingwa package to provide the compiler. Other options are available as well, but that's one that I've had the most success with. And if you're looking to build for Android, you're going to also need to have the SDK and NDK installed. That's probably easiest through Android Studio, although any packaging system that supports them should be suitable. If you have all of those set up, then before you start your first app, you might want to try out the Fyne demo application. To do that, you can just use go get with -u in case you've downloaded it before, fyne.io/fyne/v2/cmd/fyne_demo. If you're using a more recent Go since 1.16, you might need to say go install instead to avoid deprecation warnings. And once that's installed, you can run it using the fyne_demo command, and you'll see an application that looks something like this. It's going to load in a dark or light version of the theme according to your system preferences. And you'll probably see that the font size and so forth will adjust to the platform that it's running on as well. You can run this demo on iOS and Android as well. In fact, we have uploaded it to the Google Play Store so that you can check it out. Unfortunately, it's not on the Apple App Store because they don't allow demo applications in this sort of a way. But you can install it on your own device, and I'll show you how to do so later. So let's get started with some code. Well, first of all, we need to make a project. So here I just illustrated creating a new project folder. You need to initialize your modules, assuming a recent version of Go, and then we get fyne.io/fyne/v2, which includes the Fyne into your project dependencies. And now we're going to edit our first file. We'll just call it ui.go. Other names are available. And here's the code that you're going to put in your very first Fyne app. There's not much to it, but let me just go through the lines. Firstly, of course, we declare that this is in the main package so that it can be an executable that's run. We're going to import the app and widget packages from the Fyne project. I use that shorthand throughout the presentation so that I don't have to go through the full path each time, but they are consistent, as you can imagine. And then we have our main method. The 4 lines of code are as follows. We create a new application. I'll come back to what that means later. With that application handle, we can create a new window. We title it Hello, and depending on the operating system, that may be visible above the window in the border area. We then set the content of this window to be a new label widget, created there with widget.newLabel, and passing it the content to display. And lastly, we tell the window to show and run, which is a shortcut for showing the window and running the application. If you were showing more windows, you could do that. You only need to run the application once. That's just how things are set up. So that's all the code you need. And we can run that using go run full stop to mean the current package. You could also type go run ui.go, as we only have one file. And doing so will result in a window much like the one that you see here. It's packed to fit the content that we've defined, and this time it's loading in the light theme, which matches the system that it was running on. And that's all there is to get running with your first Fyne application. Let's talk a little bit more about the way that this drawing is supported and how the widgets are defined, what we can use to build our more complete applications. So let's start with the canvas and how this is created, because there's quite a lot happening underneath the hood. So the canvas is the content of a window, and it's handled by the driver internally, and that's going to handle the input and the output for your application. And also we have a driver that is able to run test scenarios, which we'll come back to as well. The primitive draw objects, called canvas objects, describe objects that can be drawn. These are all in the canvas subpackage and include things like rectangle, text, image. They define the data about an object, and that's passed into the driver to render them when requested. Each of the items that we define, whether it's a canvas object or a more complex widget, is rendered when requested, and then we cache that rendering until something changes with that widget. We can ask any element to refresh when something has changed. It'll often happen automatically, and that's always going to make the smallest change necessary so that our application runs as fast as possible. A widget, unlike a canvas object, has a separate concept of a widget renderer behind the scenes, which allows our widget API to focus on behavior and expected outcomes than how it's going to be drawn on screen. And that's part of the Fyne design, so that the API is really succinct and describes the expectations rather than tweaking the graphical setup all the way through. An example that might help here is that there is a label widget that we saw earlier, and there's also a text canvas primitive. The label is going to automatically handle things like the theme, layout, and stay up to date with the user configuration, whereas the text as a canvas primitive is going to do exactly what is required based on the color, font size, and so forth that's specified. So you can choose the one that's appropriate for your needs. Each of the canvases has a capture method that allows us to save the content to an image. This may not be particularly useful for many applications, but can be really helpful during testing as well. Like I mentioned before, there is a test driver that enables you to run TDD on all of your graphical apps. And that isn't going to display on screen or actually use the hardware mouse. And so if you need to verify what was drawn, you can do so by saving the capture result to a file. Now that might all sound very complicated, but this is all going to be managed automatically for you. When you call app.new, it's going to explore the current runtime, see what's available on the system, and wire up the correct driver and canvas capabilities so that your applications just run, and you can forget all about this information and just write your application. So let's look at the canvas containers, how they're laid out, and the items that we can put in them. So like I said, a canvas is the content of a window, and to make it show anything, we're going to want to put some content inside it. The canvas objects there are both the primitive elements, but also the base object type for everything that we can put in our window. So we could place a canvas object there, or we could choose to combine them using a container. This is what allows us to put more than one element into the space available. The container is managed by the layout that's set on it, and the container package has various helpful functions that will allow you to set these up really easily, such as container.newBorder, which allows you to specify items that should be placed around the outside of a window, and the content element will stretch to fill the inside space. A widget, like I illustrated earlier on, is the interactive version of a canvas object. This provides the majority of the functionality needed for our standard widget library. And at this point, you can extend to create a new widget that adds new functionality and hook in to various types of interactions, either to add new functionality or to intercept standard functionality and decide whether it should be executed, like filtering keystrokes into an entry, for example. And of course, because of the Go publishing and package imports, these items can be shared and then included in any other application. So let's look at the standard widget package. So I've grouped the widgets into three elements. We have basic widgets, input widgets, and the collection widgets. Let's start at the basic. To use these, you'll import the widgets package like we did in the Hello World. And once you've done that, you can do as we did, new label. You could have a button or a button with an icon as illustrated here. And that takes a callback function that will be executed when it's tapped. You could display a progress bar using new progress bar, or group a few elements together using new card. And recently, we also added the ability to show more rich textual content there. And the rich text widget can be configured manually through an API or automatically by passing markdown content into the constructor. There are many other widgets. I didn't want to go through every one of them. There are too many to cover, but you could also see here the text grid. We have a hyperlink, a toolbar. There are some more advanced widgets that allow you to manage child widgets, and these are in the container package as well, such as the app tabs, and there's a doc tabs as well, and also a split view, among many other helpful things that will allow you to arrange your application and its growing amount of content. Those are the basic widgets. Hopefully you can see that it's quite easy to guess what the constructors might be, and if your IDE is set up with autocomplete, you shouldn't have any trouble getting those working. The next group of widgets is the input widgets. So this is where you might be expecting the user to provide some data to you that the application is going to operate with. So we start with an entry widget. That is no surprise there. And then the new password entry, which sets the password field on entry so that the contents can't be seen. We have a new slider. You specify from the minimum to the maximum, and you can set up callbacks on that, like all of the other input widgets as well. A check. This is a standard checkbox with a Boolean callback when it changes. You can have a radial group as well. There's also a check group if you want a group of the checks instead of a single one. And a select input widget there that allows you to choose between different options. As well as those inputs, we have validation. So your entry widget can be checked against certain criteria. And a form, which allows you to group these things and automatically handles the user accepting the content in its current state and passing it in one go back to your application. And then the third group of widgets that I mentioned is collection-based widgets. These have a slightly different API because they're about handling huge amounts of data and still keeping an application that's really performant. So here you can see a list, and that could contain tens of thousands of items, but we want to make sure that it's very quick to operate on. So clearly we can't load all of those items at once, and that's why the collection API is a little different. So we again start with a familiar constructor, newList, but this time we pass 3 callback functions instead of static data. So imagine we have a variable called data, which is a slice of some items, and here the first function is how many items should we have in our list, and so we return the length of the data. The second callback function is the create item callback. And so here we create a template object. This is to be used in a caching mechanism. Anytime a new item should be displayed and we don't have an item in our cache, we're going to call this to create a new template. As well as passing the contents that will be used, the size of it indicates the minimum size of the list. In this case, the width of the list, because we scroll vertically. And so template object reserves that much space. And lastly, we have our callback that is going to be called every time an item is brought into view, whether it's from the first time we're creating the list or as the user scrolls. So here we make use of the template object passed in, and we apply our data based on the ID of that that's been requested. Here we call setText on the widget. I hope that makes sense. It's a little more complicated than some of the other widgets, but it allows really powerful and fast presentation of large data. We have 3 widgets. The list is the simplest. The table is used to display a 2-dimensional grid, and you can set the column width for a bit of variety there. And also there is a tree widget for something that has a hierarchical nature to the data. As well as standard widgets, we also have other really helpful APIs like dialogues and file pickers. So here you can see a simple confirm dialog being displayed above the Fyne demo application. We create this dialog by calling dialog.showConfirm after importing the dialog subpackage, and we pass it a title and the text to display. We are also given the opportunity to pass a callback function, and the boolean passed into that will be the negative or positive response from the 2 buttons displayed. And lastly, we pass it the current window because dialogues in Fyne appear above the canvas of the current window. This is a little different to some other toolkits, but it applies much better across multiple different platforms and means that the workflow is clearly that the dialogue is interrupting what's being done on screen instead of popping multiple windows that may or may not be important. Here you can see the confirm dialog in the light theme, and also I'll show you the file open. So again, it's in the dialog package. We call show file open, and the second parameter here is the window as before. The first parameter in this case is the callback when the user selects an item from the file dialog. We'll see a little bit later what a URI read closer is, but you can see that that is the entry point to the data that was chosen, or an error might be passed if there was a problem. So those are the standard elements for an application and its graphical presentation. But as I hinted, there's things that are also important for a good cross-platform graphical app, and that is the data and how things are accessed or stored. So let's cover that next. One of the complications about building an application that could work on so many different platforms, first of all, is file access. Because certain systems run applications in sandbox modes, and also it's possible for applications to receive data in a way that's not necessarily through the file system. For example, your Android or iOS device might allow you to choose data that could be imported from one of the other applications. And so we've had to put an abstraction on top of the file and data access. So let's look first at the files. The cross-platform API that we've provided means that you can always use the same code no matter what platform you're running on. It allows access to both items on the file system and also the external data sources that I illustrated before. It could also be used to access remote file systems if you provided an appropriate repository. We automatically have wired in the file, HTTP and HTTPS repositories, and also the content providers from Android and iOS. But how do you use this? Well, it's based on URIs, as you might have noticed in the previous example, and you can create a URI by parsing a string, or by creating a new file URI where you pass simply the path and the URI is created for you. And once you have one of these, you can use standard operations to read or to write the data from your system. The URI is going to be used to look up an appropriate repository for the data, and you will be passed a read closer or a write closer if that was successful. As is hinted at the name, it's important to remember to close the data when it's returned, when you're done with it, so that you don't accidentally leak resources, whether it's file system or pipe, to an external data source. And of course, you can list as well if you're interested to know what other child elements will be available in a URIs that's representing a directory. There are of course lots of more. You can see them in the storage package, which you should of course import before you use these APIs. That's to gain access to file data directly, and that correlates with the APIs that we saw in the file dialog. But if you just want to save some data for your application and you're not really concerned about where exactly on the system it is, we've added a document storage API as well. So this is going to give you the opportunity to name documents and that they can be created, read, written, and maybe deleted by your application alone. The items that are created by your application will appear also in the sidebar of the file dialog so that users can quickly find the data when they're running your application. The API for this is accessed through your application instance. You can call storage to access the document storage instance, and on that you can call these methods. Create and open will, as you might expect, create a new document or open an existing one, giving you write access to the new document or read access to one that you've created before. And of course, you can save data into an existing document as well. These APIs, you'll notice, take the same URI write closer and URI read closer as the main file abstraction. And so you can use them and pass around the pointers to the same code without knowing that it came from your application's document storage instead of a file system access. You can also remove a named document if the user requests it, and a simplified list API allows you to quickly check which documents are available for your application. Also, in the data space, we've provided some convenience functions for data binding so that your applications don't have to do all of the hard work when you're working with data-bound applications. We've mirrored the standard primitives, although we haven't used every different size to keep the API nice and clean. These are going to be used to either create new value types in memory or to bind to a Go primitive where you want to have the data synchronized with an external piece of data. We also have mappings for list, map, and struct. You can specify any of the primitive types as lists. A map is called untyped because it's going to be a string key to an interface value. And struct is our version of a struct primitive, which really maps to an untyped map under the hood, and you would access fields of that by name, which just, again, keeps the API clean whilst really flexible. And most powerful in the data binding is that you can map this also to application preferences using bind preference and the type. This means that data in your application can be edited by the user and stored directly into the preferences store, and then when your application is restarted, it will be read from there and presented back into back into the user interface with really no extra code at all, which is quite a convenience. But let's just see the data binding in action as well. So our widget is going to need some data to pass in. So here we set up the new string, which is an empty string that can be bound. And we then create a new entry using that data simply by passing the string to with data version of the constructor. We can also use conversions. And so in this case, we could set up a float, and that floating point number can be converted to a string by using float to string, which would use the standard format, or float to string with format, so we can specify how that should be rendered. And then that string can be passed to a label using with data, and that would be then shown to the user as value 2.3, for example. All of these data bindings are two-way, so if we wished, we could have used an entry there instead of a label, and the user would have to write value space and then their floating point number. And if the format didn't match, then it would throw a validation error, which the form or entry widget would display as being an error, like I showed in the validation earlier. One really cool extension that we're adding to the data capabilities is cloud data. And so it's going to be possible, in fact the work is in progress, but it's not currently part of the main repository, to set a cloud provider in your application. And so here you can see that our standard app is having a cloud provider set. That will be coming from my company's code or from my application that knows how to hook into a cloud data provider. And from that point, all of the storage and preferences will be synchronized to the cloud instead of just saved to the local file storage, which means that no matter what device you're running on, it's going to be possible to have that data available immediately on your devices. Of course, if you don't have your own cloud provider, it should be possible for the user to still get these improvements in functionality. And so there is a version where we're allowing a cloud package that will be imported to set up the application for cloud data without specifying where it's going to be saved. In this case, the user would be presented the option to pick their cloud provider from known providers and to input their credentials or set up appropriately so that the data is synchronized. On the desktop currently, that will work across all Fyne applications, although on mobile and other sandboxed areas, you'll need to set it up per application, although we're working to see if that can be improved. So we've talked a lot there about the different capabilities of the toolkit and how to build applications using it. But let's now look at how we can test our application and distribute it once it's running to our satisfaction. I mentioned test-driven development before, and so now let's have a look at what that really means in our graphical app. So here I have a trivial example about how it could be done. I'm using the testify package as you might in your tests, and we're importing the test subpackage from Fyne as well, which provides certain helpers. In this code here, the main function is testing that we have the correct selected text if we double tap on our entry. So we set up an entry widget and we use the test package to type the word hello into it. We check that the text of the entry equals the string hello, so we're on the right path. And then we use the test package to simulate the user having double tapped inside it. At that point, we are then going to check that hello is the contents of the function returning the selected text. And if that succeeds, we're going to also validate that the cursor column has moved to column 5. So that kind of declarative text is what we're designing to make possible for all of the standard widgets. And you can run them without any special functionality required or additional packages. Here, we've just edited that test file, and we can simply run go test in the same way you would with anything else. These tests are going to run on any continuous integration system or platform with your Go compiler, and you won't see anything flash up on screen. As I mentioned before, the test package is designed to work differently to the main packages. For drivers, it's not displaying to the screen, it's all running in memory, and so it's going to render behind the scenes, run the user interactions, and your tests will succeed very quickly indeed. If you wish to verify what the tests have achieved, then you can capture the canvas and either save it to a file or compare that to a master test data file, which there are helpers for in the test package as well. So our application has been written, the tests pass, and now we would like to package it for release. Okay, so how do we go about doing that? First of all, you're going to want to install the Fyne helper tool, which you can get using the go get command again from fyne.io/fyne/v2/cmd/fyne. And so to package your application for the current operating system, you can use Fyne package. And that's going to basically take the output of a standard Go build and wrap it in the appropriate metadata and formatting for your current operating system to understand it as a graphical app. On Windows, we're just injecting an icon file. On Mac OS, that's going to bundle a .app bundle that could be double-clicked like a normal application or dragged into any place you like to keep your applications. And for Linux and BSD, it's going to package up various files like a .desktop file into your tar.xz file that can be distributed or expanded into your standard file system. You can distribute to other operating systems by specifying the OS as a parameter to package. Now this is going to either need the C toolchain installed on your computer, or you could choose the alternative of running inside Docker containers, and the Fyne Cross project will provide you that functionality if you don't want to manage the toolchain yourself. You can also install your application onto your current computer. Here you can see that I have installed the Fyne settings application, and so my macOS launcher is able to find it alongside other applications. And that's going to work on other operating systems as well. If you have the Android SDK and NDK installed, then you can use Fyne install to upload that onto your Android device. And similarly, with the appropriate certificates from Apple, you can install that onto your iOS device, like I've done with a few of my favorite Fyne apps here. So we have now packaged our application and installed it on our own devices, but we also want to think about distribution. So the Fyne command that we used before has a release mode as well, which is going to help us to share our applications with other people. So the parameters required vary based on operating system. Here you could see that perhaps on our Windows computer, we're specifying that we would like to release with that app ID, which is going to be used in the application metadata. On iOS, for example, we will need to specify the provisioning profile and the certificate name that we downloaded from Apple to be able to do so. And the result of this command will be a file that we can upload using their standard tools directly into the App Store. And similarly with Android, we specify the key store where our private information is stored, and then the resulting APK file can be uploaded directly into the Play Store. The parameters here can get a little bit confusing, and so in the latest release we've added a new file, a metadata, alongside the project called fyneapp.toml, and that means that certain standard options can be ignored in all of the commands that you're using by specifying the data in here instead. Doing so is completely optional, but it does mean that you can save your application's data into the repository instead of remembering it for each time that you invoke the Fyne commands. And so there we have the details about how you would distribute your application as well. But there are lots of applications out there which it would be really great to have a look at. Unfortunately, I think I've run out of time to run through them all directly, but you can have a look at the 40 to 50 applications that we know out there that are open source and readily available for download and for code inspection and inspiration at apps.fyne.io. These will download and run on your desktop computer like any other Fyne application that we've discussed earlier. And there is a version of the site that you can access through the links there that show you the applications that are available through Apple's App Store or the Google Play Store as well. And just to show you a little taste of what's available here, the yellow front and center in the bottom left there is a Notes app that has applied a custom theme to get the slightly skeuomorphic feel of a yellow Lego pad. Behind it is an application from the apps repository that helps you to install and manage the applications on your desktop, so you don't have to hunt them down. It will be made available through a lightweight app store like environment. On the top right, you could see a chess application that was made through live streaming over about 3 hours, I think, and it has the standard rules coded in, drag and drop for the pieces, and some simple game mechanics. You should check that out if you're interested in something a little bit less standard application looking. Hidden away in the background is a login manager that I've called Fyne, and that's part of our Fyne Desk suite of applications that are being pulled together to show that a Fyne toolkit is going to make for a really nice desktop environment on Linux and BSD. And lastly, the bottom right there is Fyne Term, a terminal application that's bringing the same vector graphics and colors, themes and so forth to desktop application, all written in Go, as you might expect. And that just makes working with terminals so much nicer than some of the earlier built items that dragged perhaps the legacy that was mentioned at the beginning of this presentation all the way forward. If you have an application and you would like to see it included in our listing of available applications, then you can have that added if you simply go to developer.fyne.io/submit and give us the information about what you have built. It will be included in the listings. If you would like to be involved in the project, there are a whole bunch of links here, and we'd love to see you, whether you are wanting to learn more or give something back to the community. You can start by going to developer.fyne.io, where most of our documentation is hosted. If you prefer learning through video and live code examples, they're hosted on our YouTube channel there, which is called Fyne-io. If you'd like to contribute to the project, we would be really happy to see you. We're looking for people to help with coding, testing, documentation and design. In fact, every element of the project is definitely open for new contributors any day of the week. You can see all that we're working on at GitHub. The main project is the Fyne repository in Fyne-io organization, and you should browse there for different applications, examples, and also a FyneX repository where early widgets can be contributed and may get included upstream later on. Of course, we would absolutely love it if you would choose to sponsor the project as well. You can see various different types of sponsorship opportunities available on our main website. And if you're looking to take Fyne into your business as the toolkit of choice, and you find that you would like more support than is currently available through the community, there is commercial support from various organizations available, and I'm going to just promote Fyne Labs here because that's where I'm working, and we'd be really happy to help you out. Before I go, I'd just like to take the opportunity to also thank Pact for having supported the project and helping me in writing a book both about Fyne and a previous one exploring the different Go GUI alternatives that were available 4 years ago. And they have kindly offered to make 10 ebooks available to anybody who gets in touch with me before the 27th of October. I know that Go West has some giveaways in person as well, so you should definitely check that out if you're at the event. But if you're here remotely, then this is your opportunity to potentially win a copy as well. Thank you ever so much, everybody, for your attention. I hope that you find this talk interesting and that you go off and build something really cool. We'd love to see what you've built and also to welcome anybody that would like to join us in the Fyne channel on the Gophers Slack server. I'd also like to take the opportunity to thank all of our sponsors and to every one of our contributors, big or small, because the project wouldn't be what it is today without your help. Thank you again, everybody, and enjoy the rest of your day.